What's up, guys? You're welcome to a new lesson. A redox reaction is like a boxing match between two reagents, an oxidizing agent and a reducing agent. With our discussion so far, you should already know what makes a substance an oxidizing agent and what makes a substance a reducing agent. An oxidizing agent is the reagent in the reaction that causes the other species in the redox reaction to be oxidized. It accepts electrons, thereby reducing its oxidation numbers. Therefore, it is the reagent in a reaction that is reduced. The reducing agent is the reagent that causes the reduction of the other species in the reaction. It donates electrons, which increase its oxidation number. Hence, it is oxidized in the process. A fact to note is that a substance may be both a reducing agent and an oxidizing agent. It all depends on the opposite reagents. If substance A reacts with substance B, and B accepts electrons more readily than A, that is, B is a stronger oxidizing agent, then the substance A would have to act as a reducing agent. On the other hand, if substance A reacts with substance B that donates electrons more readily, that is, it reacts with a stronger reducing agent, substance A would have to act as the oxidizing agent. Take water for example. Water is a pretty balanced but reactive substance. When it reacts with red-hot carbon, water acts as an oxidizing agent because carbon is a strong reducing agent. So water will lose its oxygen to carbon, which in turn shares its electrons with the oxygen. On the other hand, when water reacts with fluorine, it acts as a reducing agent. Water will lose its hydrogen atoms to fluorine, which accepts electrons very readily. Fluorine, therefore, is the oxidizing agent here, while water is the reducing agent. All substances can either accept electrons or donate electrons, depending on their reaction. But some substances are so electronegative that they almost always accept electrons or give away oxygen. These substances are often used as oxidizing agents. Examples include acidified potassium tetraoxomanganate 7, acidified potassium heptaoxodichromate 6, manganese 4 oxide, and hot concentrated tetraoxosulfate 6 acid. As you can see, these oxidizing agents all have sufficient oxygen atoms to give away, and this is why they are very good oxidizing agents. Some other oxidizing agents include oxygen, electronegative elements such as chlorine, and metallic ions from salts of unreactive metals such as silver. Some other substances are so electropositive that they are always ready to give away electrons. Therefore, they are strong reducing agents. They include reactive metals such as iron and sodium, hydrogen, the hydrogen-rich ammonia, and carbon. You also have non-metallic ions and substances that can easily move to a higher oxidation state, such as carbon 2 oxide and sulfur 4 oxide. Generally, metals and non-metallic ions act as reducing agents, while non-metals and metallic ions act as oxidizing agents. In further lessons, we will be testing for oxidizing and reducing agents. Meanwhile, here is a summary of this lesson. In a redox reaction, one reagent has to act as an oxidizing agent while the other acts as a reducing agent. Substances act as oxidizing or reducing agents depending on the reaction conditions and the substance with which they react. Some substances are strong oxidizing agents, while others are strong reducing agents. I would love to see you in the next lesson.